Okay, so class, good day and assalamualaikum. So today we are going to start with the first lecture for chapter 3 sequences. So in this chapter we have 4 subtopics. The first one is the general sequences, and then the second one is arithmetic sequences, and the third one 3.3 is a geometric sequence. Okay, and the last one 3.4 is application of arithmetic and geometric sequences. Okay, so for this lecture, the first lecture, we are going to focus on the sequence, the general sequence, and arithmetic, and the application of arithmetic sequence. So we are going to focus all about arithmetic for this lecture. At the end of the lesson, students should be able to first express the nth terms of sequence. Sebutan ke n. So n can be any value. 3.2a, find the nth term and sum of the first n terms. So sebutan ke n and hasil tambah n sebutan pertama. Okay. 3.4a, solve problem involving arithmetic sequence in business and economic. So we are going to focus the application in arithmetic first. So what is definition of sequence? So if you learn in your school, sequence or janjang in Malay. A sequence is a set of order numbers arranged in particular order. For example, 2, 4, 6, 8. So what can you explain about this set of number? So it's adding up by 2. Right? So 2 plus 2 equal to 4. 4 plus 2 equal to 6. 6 plus 2 equal to 8. So every time we go to the next term, we add up another 2. So this is what we call a sequence. It's arranged in particular order. And a set of order number. This number is following the order. We cannot just write 4, 2, 8, 6 and that. Okay, so we have to follow the order. The numbers which form the sequence are called terms, sebutan. For the above example, 2 is the first term, so first term, 4 is the second term, and so forth. So this 6 will be the third term, 8 will be the fourth term, and so on. Okay? A finite sequence has a fixed numbers of terms. Finite, tentu. For example, 2, 4, 6, 8, 10. So we stop there. So we have the final term which is 10. An infinite sequence has infinite number of terms. So it will continue up to infinity. We don't know what the final value. Let's do some example. Find the first 3 terms of sequence defined by each of the formula. So, the Tn or the nth term or sebutan ke n is represented by 2n squared minus 1. And this be Ti is equal to I over I plus 1. The ith term. So, sebutan ke I represent by I divided by I plus 1. Okay, so how to solve for this one? Usually, we will start with the first term lah. First term means that for n equal to 1. Or for this question B, I equal to 1. So, let's do question A. So, the first 3 terms, so we need to find for n equal to 1. So, we just substitute 1 into the formula, replacing the n by 1. So, we have 2 multiplied by 1 square minus 1. So, we have equal to 1. So, the second term, the n should be equal to 2. So, T2 is equal to 2 multiplied by 2 square minus 1 equal to 7. And for n equal to 3, the third term, the first 3 terms, so n equal to 3, so T3 is equal to 2 multiplied by 3 squared minus 1. So we get 17. Okay. So let's do question B. So the first three terms are, so you have to do the conclusion here. It will be 1, 7, 17. So for question B, Ti equal to I over I plus 1. So we start with I equal to 1. So it will be 1 over 1 plus 1, which is equal to 1 over 2. So when I equal to 2, T2 is equal to 2 over 2 plus 1. So it will be 2 over 3. And T3, we replace I with 3. We get 3 over 3 plus 1, which is 3 over 4. So the first three terms are 1 over 2, 2 over 3, 3 over 4. Definition of arithmetic sequence. So we are going into the second subtopic, which is the arithmetic sequence. So an arithmetic sequences is a sequence of the form A plus D, A plus 2D, A plus 3D. So what we can say that the number of A here will be the first term of the sequence, and D we call it as a common difference, Beza sepunya of the sequence. Why Beza sepunya? If we see the second term and the first term, if we found the difference between these two terms, what do we get? So we just subtract lah. A plus D minus A, so we get D. Also the third term and the term before that, which is the second term, A plus 2D minus A plus D. So what do we get? A minus A, 2D minus D, we get D. So this D is our common difference, the Beza sepunya. So the nth term, sebutan ke n for arithmetic can be represented as Tn equal to A plus n minus 1D. So sebutan ke n adalah sama dengan sebutan pertama tambah n tolak 1 darab Beza sepunya. So A is the first term, n is the nth n, and D will be the common difference. Okay, so that's all for the formula for the nth term. So you have to remember this one lah. So remember this one so that you can answer during the exam when you want to find the nth term. Okay. Proof. So let's see the proof. So you don't have to know how to prove this one, but you don't have to remember, but you have to know lah. So let's say for the first term we get A plus 1 minus 1D because n is equal to 1, and we get A. For T2 we get A plus with 2 minus 1D, which is equal to A plus D. Third term A plus 3 minus 1D, which is equal to A plus 2D, and so on up to A plus n minus 1D. Okay, so note that if a sequence is an arithmetic sequence, there will be a common difference between two consecutive terms. Two consecutive maksudnya T1 should be with T2, T2, T3, T3, T4. It should be the one beside this value lah, that specific value term. Okay, so will be have a common difference. So the difference between the consecutive term will be the same. Okay, Tn minus Tn minus 1 is equal to D. So generally, if we find T2 minus T1, it should be equal to T3 minus T2, it should be equal to T4 minus T3, T5 minus T4, and so on. So generally, we can say that Tn minus 1, sebutan ke n tolak sebutan yang sebelum n, kita akan dapat Beza sepunya a constant. Okay. So let's do some example. Consider the arithmetic sequence below. Find the nth term of the sequence. So this question specifically said that it is an arithmetic sequence. So an arithmetic sequence, it should follow the nth term formula. So we can know that the first term 9 here is our A, right? So we have to know what is our A and D to find the nth term. So here we know that A equal to 9. So what is D? To find the common difference, you can subtract between the consecutive terms. So let's say we subtract T2, okay, here, if we subtract T2 from, we subtract T1 from T2, means that 4 minus 9. Or T3 minus T2, so negative 1 minus 4. Or T4 minus T3. So here we get negative 5. Here also we get negative 5. Negative minus will be positive. Here also negative 5. So we have a common difference of negative 5. So a common difference of negative 5 means that D is equal to negative 5. So now we can find the nth term of the sequence, which is Tn is equal to A, which is 9, plus with n minus 1 of negative 5. So this expression we can simplify it by expanding the n minus 1 with negative 5. So we have 9 minus 5n plus 5. So 9 plus 5 is equal to 14 minus 5n. So this is our answer for the n term. Example 3. Find the nth term and the 300th term of the arithmetic sequence 13, 7, 1 and so on. So as usual, we have to find out what is our nth terms. And then we have to find T300. Okay, so how to find the nth term? We need to know what is our A and D. So what is our first term? It is equal to 13 from the sequence given. Okay, so it's equal to 13. And what is the common difference? We just subtract T2 with T1. So 7 minus 13 we get equal to negative 6. 1 minus 7 also a negative 6. So we have A and D. So Tn is equal to, yes, 13 plus n minus 1 multiplied by negative 6. So simplify the expression. We get, yes, 19 minus 6. And so this is the nth term. How about the second question, which is the 300th term? So we just have to replace n equal to 300. So T of 300 is equal to 19 minus 6 of n, which is 300. So 6 multiplied with 300 equal to 1800. So we get the answer negative 1781. So this is the 300th term. Okay. Example 4. The 11th term of arithmetic sequence is 52 and 19th term is 92. Find the 1000th term. So they didn't given directly what is A and D. So we only know the information given here is the 11th term of arithmetic sequence, which is 52. So we represent it as T11 equal to 52. And 90th term is 92. So means that the T19 is equal to 92. So what we know here is only the value of n, right? So what is T11? So it's equivalent to, so I want to find is T1000, right? So T11, by using the formula of n term, T11 is equal to A plus 11 minus 1D. So A plus 11 minus 1D is equivalent to 52, which is given in the question. The same for T19. So A plus Here a plus 19 minus 1 multiplied by d is equal to 92. Okay, so after you simplify the first equation here for T11, we get a plus 10d equal to 52, and for T19, a plus 18d equal to 92. So we have two equations. What we want to find is two unknowns. So can you solve for this simultaneous equation? Yes, right. You can solve it either by using elimination or substitution, penghapusan ataupun penggantian, kaedah persamaan serentak. So, for me, I will use the elimination method because we have a coefficient of A1 for both equation. So, let's say equation 2 minus equation 1. So, A minus A is equal to 0. So, 18D minus 10D, we get 8D. And 92 minus 52, we get 40. So now we get D is equal to 5. So if we know what is D, we can find what is A by substituting D into 1 or into 2. Either one. So if we substitute D into 1, so we get A plus 50 equal to 52. So A is equal to 2. So now we know what is A, what is D. So we know that Tn is equal to 2 plus n minus 1 of 5, which is the D. So simplify, we get negative 3. If we want to simplify, so we get negative 3 plus 5n. If you don't want, you can directly, because they didn't ask for the Tn, so you don't have to simplify. They asked to find the 1000 term. So you can just directly replace the n with 1000 to find the T1000. So 2 plus 1000 minus 1 multiplied by 5. So what do we get? We will get 4997 for the answer of T 1000. Okay. Okay, so now let us see a concept of partial sums of arithmetic sequence. So what it means by partial sums of arithmetic sequence. So Sn, or this Sn is representing the sum of the first n term. What is the sum of the first n terms? Hasil tambah sebutan n yang pertama. So, sebutan n yang pertama adalah bermula dengan T pertama, T1. So, we add up to T2, T3 and so on up to n terms. Okay? And then, so let's say we know that T1 is equal to A, T2 is equal to A plus D, T3 equal to A plus 2D, and the last Tn equal to A plus n minus 1D. So, Sn can be represented as the addition of the terms. So we have A plus D plus A plus 2D and A plus 3D and so on up to A plus n minus 1D. Okay, so let's say we have this Sn and another to Sn with the arrangement inverted arrangement. So the inverted arrangement is A plus n minus 1D plus A plus n minus 2D, and the last term should be A plus 2D, A plus D, A plus A. So the arrangement is inverted here. So what we do after that, we add up these two equations. Okay, so add up these two equations. This Sn, we add up with Sn. So what do we have on the left side is 2 times of Sn. Okay, so 2 times of Sn, and the right side, what we have, we add up the first term from the first Sn with this first term of the second Sn. The second term, first Sn plus the second term of the second Sn. So what do we have is 2 times of A plus with n minus 1D. Here also 2 times of A plus n minus 1 of D. And The next one, 2 times of A plus n minus 1 of D up to the n. Okay, so how many times of this? We have n terms, right? 1, 2, 3, dot, 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 up to n terms. So, we can simplify that. We have n term of 2a plus n minus 1d on the right side of the equation. So, we can take out n as the coefficient of these terms 2a plus n minus 1d. And then the Sn can be concluded as n over 2 of 2a plus n minus 1d. So this is the general formula for the sum of the first n term. Okay, so this one is the formula that we will use to find the sum of the first n term. Please remember this formula. Okay, so Sn with the formula of n over 2 multiplied by 2a plus n minus 1 of d, we know that the nth term is equal to a plus n minus 1d. So this 2a is equivalent to a plus a. So this a plus n minus 1d is actually the final term of in the summation of these n terms, right? So this is actually the Tn. So we can represent the Tn as the last term. So A is the first term, L is the last term. This is first, this is n term. Okay, so if we know already what is the last term, we can use this second formula here to find the sum of the first n term. Okay. Note also that Tn is equal to Sn minus S of n minus 1. How? This Sn is equivalent to T1 plus T2 plus T3 plus dot 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 plus Tn minus 1 plus Tn, the last term. And S of n minus 1 is T1 plus T2 plus T3 plus dot 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 dot. The last term should be T of n minus 1. So if we subtract Sn with Sn minus 1, so T1 will be cancelled out, T3 also, T2, and Tn minus 1 also. So what's left is only T of n. Okay? Example here. Let's see some example. S1 equal to T1. S2 is equal to T1 plus T2. So T2 is equal to S2 minus S1 because T1 can be cancelled out. So we left with T2. Okay. So let's do some example. So example 5. Find the sum of the first 50 odd numbers. So first 50 terms of the odd numbers. So how to represent the odd numbers? Okay, so we know the odd numbers is 1, 3, 5, 7, dot, 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 up to the 50 terms. Okay, so now we have to find what is the 50th term. Or you can just directly find the common difference and the first term of the formula. Why? Because we know already what is the n here. So you have two choices to solve for these questions. So the arithmetic sequence of the odd numbers is that we want to find the S50, right? So we have to know the formula for the S50, which is equal to n over 20 multiplied by a, 2a plus n minus 1d. So we have to know what is A, what is D. And we know already which is equal to 50. So what is our A? From the sequence here, we know that A is equal to 1. What is our D? D is a common difference, so we just have to subtract the Tn minus 1 from Tn. So let's say T2 minus T1, we get 2. T3 minus T2, we get 2. So n is equal to 50. So directly we just substitute all this value A, D, and n into the formula. So S50 equal to 50 over 2 multiplied by 2 of A, which is 1, plus with n, which is 50 minus 1, multiplied with D, which is equal to 2. So what do we get here? So the final answer is equal to 2,500. Okay, so let's say we want to find by using the other formula, which is Sn equal to n over 2 of A plus L. So we need to find what is our L. L is T50. So T50 means that we know we need to add up 1, the A, plus 50 minus 1, which is 49 of 2. Right? 2 is D. This is 50 minus 1, the n minus 1. So we get 49 multiplied by 2 is equal to 98. So it's 99. So for this formula, we have 50 over 2 as 550 multiplied with 1 plus 99. So this is 100. 100 divided by 2 is 50. 50 multiplied by 50 is equal to 2,500. So we get the same answer if you use the second formula. So to solve this part of question, we have to decide which one is easier, which one is the shorter. Okay, so we don't want to waste our time in using the longer method. So example 6. The R term of an arithmetic progression is 1 plus 6R. So this is TR. So TR, TN is the same because it's just a variable. Find the terms of n, sum of the first n term of the progression. Okay, so let's say this is R term of arithmetic sequence. So find in terms of n, sum of the first n terms. So we want to find sum of the first n term. So what we want to find is actually Sn. So Sn with the formula of n over 2 of 2a plus n minus 1d. So if we use this formula, we need to know what is our a, what is our d. Right? But what is our a? Do we know what is our a and our d? So we only know TR equal to 1 plus 6R. So what we should do from this term, okay, T1 is equal to 1. So T1 is equal to A. So if we want to find T1, so we use this formula by replacing the R with 1. So we have 1 plus 6 multiplied by 1, which is equal to 7. So that is our first term. How about D? To find D, we have to find the other terms, which is T2, and find the difference. So for T2 is equal to 1 plus 6 of 2, which is equal to 13. Right? So the difference between T2 and T1, we get the D, which is 13 minus 7 equal to 6. So this is our D. So we can replace this value A and D into the formula to find the Sn. So okay, so the sum of the first n term of the progression is Sn equal to n over 2 of 2a, which is 7, plus n minus 1 of d. So simplify, we have 14 plus 6n minus 6 inside the bracket, which is we will get n over 2 of 8 plus 6n, which is we can factorize out to here, which is equal to 4 plus 3n. Right? So 2 divided by 2, so we have n of 4 plus 3n as the final answer for Sn. Okay? So, example 7. How many terms of arithmetic sequence 5, 7, 9 and dot 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 must be added to get 572? So, this is the sum of n. But we don't know what n is it. Okay, because we don't know how many terms being added to get 572. So, that n is the thing that we need to find. So, here we know how many terms. So, how many terms? How many terms? So, what is the value of n? So, that's the question we want to find. And we know that Sn equal to 572. And the sequence is 5, 7, 9. So, with A equal to 5 and D is equal to 7 minus 5, which is equal to 2. Or 9 minus 7 equal to 2. So, because we know the value of Sn without the n, so we just have to replace everything inside the formula of Sn, which Sn equal to 572 and n over 2 is unknown, but we know A and D, so 2 of A, which is 5, plus n minus 1 of D, which is 2, equal to 572. So we can eliminate these two by multiplying 572 by 2, so we get, oh, they're not multiplying, they just factorize out the 2 here. So we have 2 of 5 plus n minus 1. Okay, so these two can be cancelled out. We don't have to expand already. So we left with n of 5 plus n minus 1 equal to 572. So this is n. If we expand it, we will get a quadratic. So a quadratic, to solve quadratic, we have to make sure the right side equal to 0. That's why after we expand it, we will get 5n plus n squared minus n. So it will be n squared plus 4n, and then this 572 will be on the left side, minus 572 equal to 0. So, factorize out this value, use your calculator, we will get the answer of n equal to 22 and n equal to negative 26. So, in factorized form, we have n minus 22 multiplied with n plus 26 equal to 0. So, our n equal to 22 and n equal to negative 26. So, which one should be the answer? Logically. Okay, so by n kita sebutan ada berapa banyak? Logik tak kalau n kita negative 26? No. So, we have to reject this one. So, the final answer n should be equal to 22 because the n should be a positive value. N is a counting number, so it should be a natural number. Okay, natural number should be more than 0. So n is equal to 22. So how many terms? 22 terms should be added to get 572. Okay, so this is the conclusion. Now, if we write down in a sentence form, 22 terms must be added to get 572. Okay, so arithmetic problem. So now we are going into the application of arithmetic. Note that a problem involving arithmetic sequence can be identified if the sequence in the problem show that there is a common increasing or common decreasing value in the form of constant amount. So it will adding up with a constant value. It's not changing. Okay, or it will decreasing by a constant value, a constant that not changing. However, use some reasoning to the situation in the problem to solve, to justify whether the question consists of term or sum of arithmetic sequence. Okay, so kita kena guna some thinking lah. So you have to deduce or something to conclude whether the situation using the arithmetic sequence or not. Recall back the formula. So Tn is equal to A plus n minus 1 of D. as n is equal to n over 2 of 2a plus n minus 1 of d. So example 8. So this is a situation. So Ani saved her money to buy a new car. The first month she saved 400, and then every month thereafter her saving increases by 100. So every month thereafter. So let's say the first month 400. So the second month should be, so we add up by 100, which is 500. So the third month should be, we need to increase by 100 so it will be 600. So find how much money should she save in 12 months. So in 12 months, dalam masa 12 bulan dia dah boleh kumpul berapa banyak. Okay. And then the total saving after 12 months. So how much money should she save in 12 months? So bulan ke-12 berapa banyak yang dia simpan? Bulan pertama 400, bulan seterusnya dia akan tambah 100, tambah 100, tambah 100 and so on. So how to interpret the question? So how many saving, how much money she should save in the 12 months? So bulan ke-12 berapa banyak yang dia boleh simpan? Itu maksud dia. So what this state about? What we want to find is actually sebutan ke-12. Betul tak? Bulan 12 berapa banyak dia boleh simpan? Sebab bulan pertama 400, bulan kedua 500, bulan ketiga 600 and so on. And question B, the total saving after 12 months. So bulan-bulan dia simpan kan? So duit yang dah terkumpul selepas 12 bulan tu berapa? So question A is talking about the 12th term, right? And question B is talking about the sum of the 12th term. So now the first month is equal to 400. We can represent it as A, which is equal to 400. And the D, it will increase by 100. So D 100 is equal to D is equal to 100. Because the saving monthly is 400 and add up 100, 500 and add up 100 next month, 600 and so on. So it's an arithmetic sequence lah, because we have a common difference of 100 each month. And then what we want to find is Tn. So Tn is T12 here. So we just have to substitute into the formula. A equal to 400. Okay, so it's talking about B also. B is about S, sum. So now we want to find T12 first. So T12 is equal to A plus N minus 1D. So A is equal to 400 plus N 12 minus 1 multiplied by 100, which is the D. So we get 1,500 on the 12th month. Okay. So we get the answer for the how many money she should save on the 12th month. And for question B, they ask for the sum. What is the total of saving she will have? So on the 12th month, the total should be adding up between T1, T2 up to T12. So we can use the formula of Sn, which is n over 12. So n equal to 12, n over 2, 12 over 2 multiplied by 2 of the first term A, which is 400, plus 12 minus 1 of the difference, common difference is 100. So simplify by using a calculator, we will get the total saving after 12 months is equal to 11,400 ringgit. Okay, so Ani, the total saving after 12 months is RM 11,400 ringgit. So you have to do the conclusion for the application questions. Okay, so this is how you apply the arithmetic sequence into the real life situation. Okay, so that's all for arithmetic. So stay tuned for the next lecture for the geometric sequence. Thank you, class.